Hello, welcome back to Miss Bell's classroom. Today in class we're going to be learning about auroras. So we'll be talking about the auroras in the north and the auroras in the southern hemisphere. So I hope that you enjoy this lesson. So if you're ever near the north or south pole, you may be in for a very, very special treat. Frequently, there are beautiful light shows in the sky. These lights are called auroras. If you're near the North Pole, it is called an aurora borealis, or the northern lights. And the northern lights put on a display above the snowy landscape of Bee Lake, Northwestern Territories, Canada. Auroras, also called the polar lights, are rarely visible outside. So if you're near the South Pole, it is called the Aurora Australis, or the southern lights. So Antarctic aurora, the southern lights swirl over the South Pole. Auroras are produced by the interaction of the Earth's magnetic field and solar wind, a string of protons and electrons streaming from the sun. And then we also have auroras from space. So the image of the southern lights here. Here's a photograph of it. This image from the southern lights was taken above the Indian Ocean. So you can see this beautiful view of the aurora, and it was taken up from the International Space Station as it crossed over the southern Indian Ocean on September 17th, 2011. So you can see this beautiful colors here. It's beautiful. So it was taken by astronauts on the International Space Station, and auroras happen when ions or charged particles in the solar wind collide with atoms in Earth's upper atmosphere. The atoms are excited by these collisions, and they typically emit light as they return to their original energy level. Here's just another photograph. It's very similar, but you can see the colors. Here it's the same photograph pretty much. But you can see the beautiful colors illuminating. So you can see it's glowing green. So the northern lights shine over the Skittenelv, Norway. As the solar wind strikes different particles in the Earth's atmosphere, the particles glow with a different color. So oxygen glows green, for example, while nitrogen glows purple or red. So if you look here, it's glowing green. So what would that be? Oxygen, good. So auroral beads seen from the International Space Station on September 17th, so this photograph here. NASA studies aurora as they are visible markers of space weather and processes around Earth. So, named for the Roman goddess of dawn, the aurora is a captivating display of light in the night sky. The aurora borealis and the aurora northern lights and southern lights occur at the northern and southern poles, and occasionally space weather interacting with Earth can cause auroras to extend even further away from the poles. These colorful lights are constantly changing shape and intensity from dim and scattered to bright enough to read by. The dancing lights of the aurora provide spectacular views from the ground and also capture the imaginations of scientists who study incoming energy. So scientists study auroras to better understand the complex space environment, which in turn can help predict and help mitigate its effects on communication signals and human technology. The sun continuously produces a solar wind made of charged particles that flows outward into the solar system. When the solar wind reaches the Earth's magnetic field, it can cause magnetic reconnection, an explosive process that allows charged particles from space to accelerate. Earth's tear-shaped magnetic field, called magnetosphere, continuously responds to the changing intensity of the solar wind. The solar wind particles funnel around the long tail of the magnetosphere, where they become trapped. When magnetic reconnection occurs, the particles are accelerated towards Earth's poles. Along the way, particles can collide with atoms and molecules in Earth's upper atmosphere, an interaction that provides the atoms with extra bursts of light. These interactions continue at lower and lower altitudes until all the incoming energy is lost. When we see a glowing aurora, we are watching a billion individual collisions, lighting up the magnetic field lines of Earth. Scientists study auroras from a variety of vantage points, below, above, and within. From below ground, there's space telescopes and radar looks upward to track what's happening in the sky. So they're able to dramatically shift from slowly shimmering waves of light to wildly shifting streaks of color to gather observations from within an aurora. NASA uses sounding rockets that take a quick trip through space for 5 to 20 minutes at a time to fly right up into auroras as they happen in real time. NASA also supports citizen science program, the Auroras, through which people around the world help track and observe auroras. So auroras do change over time, and it gives scientists insight on how our planet's magnetosphere reacts to the space weather near Earth. Any questions so far? Okay, very good. Okay. So what makes an aurora happen? What do you think? Okay. Alright, yeah, that's a great answer. So even though auroras are best seen at night, they are usually caused by the sun. The sun sends us more than heat and light. It sends a lot of other energy our way. The protective magnetic field around Earth shields us from most of the energy and particles, and we don't even notice them. But the sun doesn't send the same amount of energy all the time. There's a constant streaming of solar wind, and there are also solar storms. During one kind of solar storm, called a coronal mass ejection, the sun burps out a huge bubble of electrified gas that can travel through space at high speeds. When a solar storm comes toward, particles can travel down the magnetic field lines at the north and south poles into Earth's atmosphere. So now we're going to talk about solar wind. So raise your hand if you've ever heard of solar wind. Okay, some of us have. That's great. So the solar wind is a very powerful stream of particles ejected by the sun. The Earth's magnetic fields displayed in blue protect the planet from the solar wind. Solar wind causes the colorful auroras around the poles as it interacts with Earth's magnetosphere. Solar can disrupt GPS and communication systems or satellites. So we're going to pretend like this is the sun. Okay, so that's the sun. Then we've got some rays coming out here and some solar wind here. Okay, and then we've got a little bit of a kind of a solar flare the sun. We've got some rays, and solar flare and solar wind coming from the sun. So we're going to label this solar wind. Okay. And then we're going to pretend like this here is Earth. I'm going to put an E there for Earth. Okay, and so the wind is traveling from the sun to the Earth. Okay. And we've got some magnetic fields here. This will be the north of the Earth, the south of the Earth. Okay. Does this make sense so far? Okay. So these are the Earth's kind of just magnetic fields around it. And when the solar wind interacts with the magnetic field, that is what is causing the beautiful displays of light known as the auroras. So just like I said earlier, oxygen gives up the green color here, and nitrogen glows blue and purple. So here's an example of kind of the blue there, but that is on a different planet, which I'll talk about in a second. So we've got the sun, and then we have some solar wind blowing off and solar flare, and it's interacting with the Earth's magnetic field, which is causing those auroras. Any questions so far? Okay, so raise your hand if you think other planets get auroras. Okay, raise your hand if you think they don't get auroras. Okay, so they do. Auroras are not just something that happens on Earth. If a planet has an atmosphere and a magnetic field, they probably have auroras. So we've seen some amazing auroras on Jupiter. So the NASA Hubble Space Telescope took this picture of an aurora on Jupiter using ultraviolet light. So this is Jupiter's aurora. As you can see, it's blue, very beautiful. And there's also auroras. Another photograph of an aurora on Saturn. So the swirls of red light are an aurora of the south pole of Saturn. You can see there. Jupiter has it, Saturn has auroras. Alright, so any questions about auroras? Okay, so how do we feel? We feel like we understand them? I hope that you enjoyed learning about auroras today. I enjoyed teaching you. I hope that you have a relaxing day or relaxing night.